Video I'm going to discuss a few more advanced topics that could be used for everyday design, not necessarily just for advanced designs. So I listed here a few things, which is flipped faces, aka FlipNormals. So it refers to FlipNormals, but basically it means flipped faces. And Backface-coloring, which is an option SelfCAD has over here. You can add Backface-coloring. Now it's on. Once you click again, it says no coloring to turn it off. And Backface-culling, which you have it over here as well. Backface-culling, and you have the idea of inside faces, which is a problem in a geometry. You have fill polygon idea, which is kind of that can fill missing faces. You have magic fix that can fix broken geometry, and the general concept of manifold, non-manifold, which are kind of these things make up this problem with manifold or non-manifold. And the idea of winding order, it's not necessarily something you have to know. It's just if you come across this terminology, just to know what this is. And this is more related about backface-coloring. So let's get started, and I'll take a general cube. I can demonstrate all of that with using a basic primitive cube. No needs any special thing. So what you have over here, I have turned on this thing backface-coloring. And just to demonstrate what backface-coloring is, I will delete a face. I'll select one face and delete them. And you can see I have backface-coloring as well in. Okay, so if I turn on backface-coloring like this, you will see that inside in this, you have the outside is one color, the inside is another color. So basically all that means is that using a concept of called winding order, the rendering engine determines what is inside, what is outside. And winding order, as I said, this is not something that really you have to know. It's just internally the way the application works. And some applications will have a clockwise, some will have a counterclockwise. It all it means is there is a way it finds how a logic that it determines what is inside, what is outside. And based on that, there are different concepts we can say. So there's one concept we can say that once you determine what is inside, give it a different color. And that's called backface coloring. So you can have in the settings, there's options to change the default color for everything, default color the outside as well as for the inside. But by default, we have this blue outside and this inside. And there's another concept that I can say backface-coloring, which is basically the original concept comes from games, heavy objects. So if you have a very big object, it takes time, it slows down the application to render a very big object. So the concept is that you can say, show me only what needs to be visible. Meaning is, if I turn around the back of the object, now I want to see only the back. If I'm the front, I want to see only the front. Things that is hidden, I don't need to see. So which this is telling me basically, don't show me things that is inside, don't show me things that is in the back. Show me only things that needs to be visible. And it uses the same concept of determining what is inside, what is outside, and what's facing the camera. It needs to be visible. So if I turn this back on, you will see it hides now things because it doesn't need to show inside and it doesn't need to show the back. So it looks like it has a hole. If I turn it around, you see everything over here because you see the outside. But this side, because it's hiding, if you turn this way, it will hide things. This will make more sense soon, that I will show a more practical example how this is done. For now, I will do this. And just how to fill when you have a hole is where you have the idea of fill polygons. So if I go to fill polygons, I can close it, and this basically fills the problem, fills the hole. Okay, so this is just theoretical, but let me show you actually real use cases, why this is helpful as a part of modeling application, and how this could be used for everyday modeling. So just to determine and show another thing before that the concept of normals, it's called normals. As I say, flipped faces is basically you flip something. So let's say first idea of flipping. So I'll go this, and there's in utilities, there's an option called FlipNormals. If I'm flipping that, you can see this basically shows me as a different color. So why does it matter? First of all, if you turn on backface-coloring, you'll see even if I didn't delete the face, even the face is still here, it's still hiding it because it looks like this is from the outside. This is from the inside. But it can also make a difference in different parts of the application. And this is what I'm going to show you in a minute. So let's go back and undo this actually. Let's undo this. Okay, so everything now perfect. So let me start with some more practical example. So I'm gonna select this face, and suppose I want to extrude this, just adding a different, let's say, a different segment over here, and that would be perfectly fine. Everything would stay okay. But what if I want to inset, and I'm doing something like this, let's say, and I extrude this? This will still be okay. But if I do the same thing and I select, for example, these faces, just this outside faces, and now I extrude that the same amount, you see now we get this inside color. And the same thing if I turn on the Backface-coloring, it looks like I have a hole over here, okay? So what happened is that whenever you extrude something, the extrusion is working based on seeing the normal. And what I mean to say it's working based on seeing the normal means is it extrudes in the direction that the face is. So if the face is pointing towards a direction, if I go over here, extrusion, this is the direction of the face that you see this kind of arrow shows. And if I go positive, it goes this way. If I go negative, it goes inside. And this actually, once I finalize it, will actually cut it out to pieces, okay? So this is how extrusion looks at it. And if I select, for example, two things, this is pointing this way, this is pointing this way, this will kind of be the opposite. It will go in this direction, because if this points one way and this the other way, the center of it, the average of it, let's call it the average normal, will be pointing this way. That's why you have all of these different settings. For example, you want to do them individually. Each one goes individually. The normal is still pointing this way, but if you go individually, you basically have two separate normals, and you have some other interesting things like connecting them and all different type of stuff. So extrusion is using these normals, but also it tries to determine which direction it needs to create the normals. So once you extrude something, it will know the direction and will keep the normals. But in some cases, in this example, it didn't know because it created this faces correctly. But over here, it thought that this is inside. But it turns out this is not inside because this is kind of a hole. And if it's a hole, this is not inside. Now, this is one example that SelfCAD may eventually automate that and detect these cases. So it will automatically flip the normals. But it can never be detecting everything because this is a general concept of flexibility versus automation. Meaning is like the more automation you do, you kind of limit some use cases. And in certain cases, especially when it comes to drawing, sometimes you do want to extrude in a way that the normals keep flipped, stays flipped, because then you want to have other functions after that that will need it to be in that way. If you always automate, you kind of remove some flexibility. So it's always the case if there are some use cases where this has to be done this way, and eventually maybe this will be automated. But nevertheless, you have to know this is flipped, and if this is using either one of these settings, either Backface-coloring or Backface-coloring, you will determine that quite easily. Now, if I'm going to fix that, how can I fix that? I would just go FlipNormals, and this would be fixed. You see, fixed FlipNormals, this would be fixed, and now you are perfectly fine. Okay, so I've shown you here an example of how FlipNormals can happen automatically. This example was extrusion, and as I said, there are different use cases in drawing. If you fill them or extrude them in different directions, that this can happen. But why does it really matter? So to show you why this matters, let me show you another example. So I'll take a basic face, and I'm going to, first of all, flip the normal of one face. Okay, so this is flipped. And now what I'm going to do is I'm going to intersect it with another object. So let's say if I take these two objects now, and oops, let's just select these two objects, and I'm going to subtract one from the other, and not a union, I'm going to subtract. So I'm going to remove, let's say, this face from this face, or let's say this from this. Yes. So if I remove this from this, look what happened. We got an object actually that is called Non-Manifold. Why is this Non-Manifold? Because it doesn't really have any volume. I can make it into a volume that I can add thickness to it, for example. Let's say if I'm adding mirror thickness, okay, I can add thickness like this or whatever. Let's say just 5 without mirror, whatever I can do. So I can kind of make this into a manifold mesh, but this is not a volume. The volume is the thickness of the wall. So what happened was that it created kind of a hollowed out shell that is basically just surfaces. This is not really a mesh. This is just surfaces that will need to be converted. So if I would, however, first fix this flip normals, so let's say if I select just this object and I flip back all of the normals, fixed. And now let's do the same thing. Then I'm going to subtract this one from this one, the same idea. Look what's happening now. Now it treated it as a volume and it cut out this volume properly the way this is supposed to work. Okay, so I've shown you basically, without explaining, two different use cases of flip normals. One was that I manually selected something to flip, and one was that it automatically fixed. So let me explain what this is actually doing. So the tool that we have over here, FlipNormals, is actually a combination of two separate tools. One tool is that it can determine something that is flipped. So if I would, for example, flip this, and now I select entire object without anything selected, just entire object is selected, and I go to this tool, the first thing that the tool is doing once an object is selected, not faces, only if the entire object is selected, it will check if everything is in the correct order, in the correct winding order, and if it finds something is not in the correct winding order, it will actually fix it, and we give a proper message. So if you see over here flip normals, look at the message, fixed normals the correct orientation. Now once this is fixed and I do again flip normals, it checks everything if everything is fixed, and if it's fixed, it understands that I want to flip the entire object. So now the entire object is flipped inside out. The next time I do it, it will basically fix it back. It's fixed. Okay. If, however, I have a problem with the geometry, so in this I'll go in to explain the inside faces and I'll show you a problem. So I'm going to make a copy of this and I'm going to move it by 100 because I know the size is 100, so I'm going to move it by 100. Okay, so now I have these two objects, and what's happening actually is that this object has still, if I combine that, it needs to remove the inside faces, because inside over here there's two things. So let me just show you. So if I go to merge them, I'll go combine. In combine, there's different options how to merge them, how to combine them. I'll use merge, and I'm not going to turn this on, remove interfaces. That's what you want ideally to do, but I'm not going to turn this on, and I'll finalize it. Now what's happening is if I want to flip normals of this, it will tell me, look at this. It failed because it's a non-manifold geometry. This is where it comes in, a problem with non-manifold. Why is this non-manifold? And if you have an object like this, maybe you imported that or you did what I just did, you may be scratching your head, what's wrong with this object? Everything looks fine. So you could try to look in like this, and you see over here, yeah, it has this edge, but nothing tells you there's faces here. It's very difficult to see. So how do you determine what's going on over here, what the problem is? Well, in this case, I would select, let's say, go to faces, and I will select all of the faces, select all. So now if I have face selected, this flip normals understands that I want to flip individual faces, and it will allow me to flip it. Okay, so what is the benefit of it? Well, now I turn on Backface-coloring, and once I turn this on, I can look inside of the object. And once I look inside of the object, I actually see I have here a face. And actually there's more than one. There are two faces in both cubes. So one is from this side. If I move around, I can see now this one. And now I click delete. Okay, so now once I deleted it, I can see the entire object here. And now I can flip it back. So let's say if I flip back the normals, it will fix it because it's already manifold. It's fixed. Everything is flipped and everything is okay. So what I just did is I created deliberately merged two objects without removing it. If you would have used the union option, stitch and scoop, or the union option from the combine, or you would use to remove interfaces, this would have happened automatically. But if you deliberately do it like I did it, or mistakenly, or import an object that has interfaces, or if you just have any other reason to look inside an object, you can always zoom in, see inside an object, but sometimes it's very difficult. If you have like a big, let's say interior design, and you design something, you want to see inside of objects, you want to work inside an object, a good way to look inside to it is you flip normals and you turn on Backface-coloring, and then you can see it. So let's say now I have Backface-coloring is turned on, and my coloring is turned on. So, but everything is okay because everything is the correct order. Theoretically, the backface calling is hiding the back faces, but the minute I show it, it shows it and it hides the other faces. So there's no real use case besides the original use case that you look at Wikipedia and other places, a backface calling, which is basically make the application faster because it hides stuff that is not supposed to show. But other than that, there's no really use case in modeling. However, once I start using FlipNormals, now it's a way of modeling because now I can see what's going on inside. I can put in inside objects, although this is not a good idea to put in objects inside because it will make it a volume within a volume, which will be problematic. But it's a good idea in general to inspect objects from inside, and maybe you want to select something and modify, work in the object from inside or whatever. But that's basically the general idea. Okay, so coming back now to the idea of inside faces. I've shown you the example, and I'll repeat the same example and show you something else. So if I had this object like here, and then I make a copy, and I'm just gonna move this by 100. Okay, so now I have these two objects, and I'm going to combine them again using merge without checking remove interfaces. So now I have this that is non-manifold, as I've shown you before. If I'm going to go to FlipNormals, it's going to give me a message non-manifold. How can you fix things like that? This is where you have geometry clean. There's a tool here called geometry clean. If you go to geometry clean, there's different options. There's remove duplicates. There is remove. I'm interested now in remove interfaces. This is the tool that I'm interested in. If I click on this, you see it gives me a message that two faces were removed. Now if I go to FlipNormals, this can already flip it without a problem, because if I, let's say, turn this off, you can see the colors, it's flipped everything. Now flip it back because it removed the inner faces. Okay, so we covered here a few ideas that can turn an object non-manifold. I want to show you actually one more example. I'm going to add resolution, one more example as far as FlipNormals, how it can make an example. So let's say if I add resolution over here, and I'm going to select some faces, let's say over here, just randomly select some faces, oops, something like this, and I'm going to flip the normals of these faces. Okay, so now you see this is flipped. Now what I'm going to do is I'm going to go back to resolution, and I'm going to make resolution 0. So it should remove everything to its minimum. You see all of this, it removed everything to 0, the minimum. But this case, this is left here. Why is this left? And the reason is because the resolution tool is also looking at the winding order, and to determine what is a face and what not, it looks at everything. And in this case, these are single faces or polygons, single polygons, so it can reduce everything to 0. But in this case, it looks at this as two separate polygons that must be determined this way because it's flipped. So it needed to keep some connections, and that's why it created this type of stuff. If I would now fix this and go to my FlipNormals and fix this, and now I go back to resolution 0, okay, and I click again, you see it removed everything. So there's just another way to show you that a lot of parts of the application are working with the same idea of looking at a winding order, and FlipNormals will adjust everything and how things are working. That's why it's quite important to have this on. A reason why actually this is not by default on always, because if you have very complex objects, you may actually see kind of leakage between certain edges. And the reason for that is there's another concept I didn't write over here, but I can explain. There's a concept from exploded vertices or not. So let me show you. So what's happening here is you see this polygon has 6 faces, or in this case its polygons and faces are the same because it's not subdivided. But how many vertices does it have? It has only 8 vertices and 12 edges. And the reason is because this vertices, if you think about it, how much you have this vertex is one vertex that is shared with 3 faces. This face uses the same vertex, this uses the same, this uses the same. To show you this idea is I'm going to give a color for it. Okay, it asks me if I want to go to vertex color. Say yes. If you get a vertex color, look how this affects everything. One vertex affects the color of this, of this, of this, because this color is basically affecting everything. And internally in 3D modeling applications, the renderer engine, which in this case is WebGL, is using vertex colors. So if I color something, technically you color faces, and if you color vertices, and if you color each vertex separately, this kind of creates a gradient. So in order to make a face a single color, you need to color all of its vertices. But that means also that because these vertices are shared with others, they will kind of have the same. So there's no way making different colors for different faces. So the idea how you actually get around that is by having something that it's called different vertices. So let's say, for example, if I take a face vertex, let's say I color this now, I can color this face separately and not this. But theoretically, if I colored this face, that means that I colored the 4 vertices from this face. But this is still not coloring these faces. So why is that? And the reason for that is that there is a concept when you have a merge vertex that's normal geometry that you need it in order to make it manifold. But there's a concept that's called explosive geometry, which treats the vertices separately for each face. And SelfCAD, and as well as many other applications, actually can switch between them, can handle both of them. When it comes to rendering, because you should be able to have colors, actually SelfCAD explodes them and it makes them each one individually. But when it comes to dealing with the 3D modeling tools, it needs them to have combined. Okay, so how does this make a difference in actual modeling? Well, let me show you an example how this can make a difference. If I, for example, take this face and I add the size for it, let's say I want to add the size in the Z direction would be 0. Okay, so kind of I merged them together. What just happened now is that I took a face and I put them together in both ways. So that face is similar to this face, has an edge here and an edge here. Once I combine them together, I have now explosive geometry in the 3D modeling application because I have duplicated vertices here and a duplicated edge that is not needed. If you look over here, I still have the same amount of edges and vertices and faces. Everything's still the same. It's just collapsed. So this is what this other tool actually in Geometry Clean is doing. I can have an option, remove duplicates. And this is basically what I need, to remove duplicates. If I click on this, look what happened. It removed one face and 2 vertices. So now you see you have only 6 vertices and only 5 faces. Okay, and only 9 edges. So basically, actually the edges are this, yeah, I think one is reduced. But you see over here, because this is basically removed, it's combined now. Now it's still, the color is still the same. It's not changing color because when it goes to the rendering engine, it's still exploding it. But while you're dealing with 3D modeling, this will be kind of combined. Okay, there are other ways of combining them without that. Not to go in too much on a tangent, but there are some other tools, snapping and other details that you can collapse that will automatically remove duplicates. Similarly to the way when you merge something, you have the option automatically to remove. So, but yeah, that's the concept. Okay, so going back to the idea here, I covered the idea of flipped faces, and I've shown some examples of how this is needed. I showed the example of Boolean tool, that without that, the volume is not properly calculated. So if I do a difference between 2 objects, that one is FlipNormals, it will kind of create a hollow empty surface without really proper volume. So that's why you need to fix it. I've shown an example how this could be automatically created, flipped faces, by using extrusion in some cases. And as I said, there could be different use cases as well, like certain type of drawings and some things like that. I've shown how Backface-coloring can help show that there is holes in an object, because then you see the color from the inside, and how Backface-coloring is helpful also to see, it will show you holes, but it can also be used as a way of seeing inside of an object if you flip the normals. And I've explained the idea that flipped faces is something that the FlipNormals will first try to fix everything, and as long as it's manifold, it can fix anything automatically. If it's not manifold, then you have to manually select the faces to flip them, and you can always select all of them and flip it, and you can always select just single face and flip them back, so you can play around, which could be used a lot. I've shown how this could be useful, for example, using resolution, where you want to keep parts of it, for example, not resolution 0, so you can just flip the normals parts of it and you know, play with these type of stuff. so it could be used a lot in modeling. I've shown the idea of inside faces, that this makes it non-manifold, as you have seen in the FlipNormal tool will tell you this is not manifold, and also a way to fix it using the geometry clean. I've also shown the fill polygons. If you have a hole, you can just click fill polygons and that will fix it. Now I want to show you an example of magic fix actually. So I'm going to go again to this object and I'm going to add some resolution, and I'm going to select some faces. So let's say just randomly again select something over here, and what I'm going to do is I'm simply going to move it out, just break the object completely, and I'm pushing it out from this side. So the first thing you can see here is that it's showing it's inside out. You can see the color, and this will show you that there's a problem. If you look at it without this color, you may not notice there's some problem. It looks perfectly fine. Actually, this is a very thin edge. It may create some problems even for a magic fix maybe. Let me just reduce a little bit, not so much give it a thin edge. I mean, magic fix will do it, but it may give unexpected results if it will have too thin edge to work with. So let me just do it something like this, and okay, so I have turned off my coloring, and now if you look at this, you wouldn't notice anything is wrong. It looks like a normal object, but if I turn on the color, you can see over here, you see it here, something that's supposed to be inside, facing away from the camera, and the same thing over here, and over here, yeah, the entire thing. If I would go to FlipNormals, this interestingly, even though it's not manifold, this is called self-intersection. The face is like one face goes into another face, which is another terminology I didn't write in this image over here, but it's basically called self-intersection. It's definitely called non-manifold. Self-intersections are also non-manifold, but somehow this FlipNormal tool actually is happy with it, and it doesn't really see anything wrong because it can trace the winding order and it can find it, but it doesn't fix it. It's not going to fix it, and you keep on flipping it. It basically just flips it between what is inside, what is outside, and it stays this way. And none of these other tools that I've shown so far will actually fix that. And this is where Magic Fix comes into play. If you go to Magic Fix, you can just have it rebuild the object, and this will basically create a new object that is completely fixed. Here you can see, actually, if you look at it a little bit, you can see these colors over here. I started explaining, I didn't finish explaining it, that why this is not on by default, that it can give you false results, because this is when you have a very detailed mesh, it can show you sometimes kind of leaks. Because this is a very detailed mesh and very tiny edges, and because the rendering is exploded, meaning it's kind of duplicated everything, when you have very tiny holes, it can leak through. I don't know if you can see it. I can see it a little bit here in the corner, a slight shine of the inside color. In some cases, it could be more obvious and really not looking nice. So that's why this is not on by default. But still, this now, if you see what happened is this rebuilded this entire object that is actually stitched from the inside, from the outside, completely fine. And even if the backface coloring is on or the backface cooling is on, everything works perfectly fine. It fixed this problem. I can show you another example, just a quick example, something similar. If you take, let's say, a cube, I'm adding again resolution to it, and I'll go, let's say, and bend it aggressively. I'm just gonna bend it so much that I actually inverted it, flipped, completely flipped. I have to turn on the no, okay, this one. So you can see now this is flipped inside out, and it has a lot of self-intersecting faces over here. And the same thing that actually the FlipNormals library with this algorithm would kind of didn't detect any problem. It's not considering it as non-manifold because it still has a widening order that is uninterrupted. However, this is completely broken, and you will have a problem with this with many other tools potentially, especially 3D printing. So this is where Magic Fix will kind of rebuild this entire object, and as you can see over here, it rebuilt the entire thing without a problem. It's kind of adding a lot of details, so you will have to go either resolution 0, that will reduce it, you have like 60,000 almost, and this can reduce it to what, 4,000, which is quite a lot. You can even bring it down more with the simplify tool, but this may reduce the quality. So you see it's reduced to 498 faces, but the quality is not as smooth as it was, but nevertheless, yeah, that can do it. So that's basically the main concept of this. As I said, it sounds complex terminology, but it's actually quite simple, and it's something that could be used in everyday modeling. I hope this was helpful, and if you have any questions, please ask in the comments, and I'll be happy to answer all of them. Okay, thank you.